Getting data in terms of numbers, or let's say in terms of like general information that can be lump summed into something that can be stored on a computer, can be made on different levels. And these levels got somewhat mixed up. What we often think of when we think of such data, of course, we think of the computer, we think of statistics, we think of machine learning, we think about all these things that we currently have when it comes to computers that calculate what is our empirical world. So these are changing, these have variance, there are glitches, there are all sorts of biases, mistakes and so on. The empirical world is imperfect, there's no doubt about it. So we are aware, and we mentioned this and discussed this so often now, that we overplayed our hand when it came to the empirical. But let's look at the other two dimensions that are also important when it comes to understanding what can be done with data. So the second dimension that we have, that is kind of on the opposite end, is about natural laws. There are such things as mathematics, as physics, and all sorts of other different things that are also measured in data, and they are somewhat closely associated with forms of data. But when you take the law of Pythagoras, this is really something that is the same every time. Geometry is somewhat the same every time. Of course, there's pure mathematics that are even more so in this case. But when you look at mathematics, there are many laws, formulas, and so on in mathematics that are very generalizable indeed. There's no margin of error. You can calculate everything and you will not make any mistakes. You might make mistakes, of course, if you measure an angle and then calculate the respective thing. But these are all our own imperfections when it comes to, again, empirical data. So in mathematics, there's hardly any room for error when it comes at least to the basics. Well, in physics, it's slightly different because we haven't understood like the deep things that make the world go around in terms of physics yet. Einstein and Planck never reconsidered, and now we are in a multiverse of theories, and all that isn't solved yet. So that's why, again, these things are represented by numbers, but these are very different numbers indeed, and they are about changing phenomena. So saying that we have information about natural facts is somewhat misleading because these are not universal facts. We haven't understood the universe as of yet, and there are still many things to come in physics at least, and presumably also in mathematics. Now we looked at these two opposite ends, that is the extreme dimensions of, say, mathematics or physics. Another example would be logic. But what about ontological information? Logic could be associated to that, but what is clearly also the case is ethics. And ethics crucially creates a link to law. Because law is the translation of ethical guidelines and principles into what is the legal apparatus of our everyday life. Crime is punished by years in prison, and there's all sorts of things associated to values that go back again to mathematical laws, such as the law of Pythagoras. There you measure, which is the basis of trigonometrics, and trigonometrics gave us ownership of land, gave us all sorts of values that were then ultimately translated into monetary values. So again, we have data that represents values, numbers, but it's quite confusing how these things then translate, because as we know, our legal apparatus tries its best, but it's still showing some sort of variance. Judges give different sentences, whether they have to preside before lunch or after lunch. There's studies showing that the legal apparatus is far away from being perfect. This is why in the American Constitution it is being said that the law should be more perfect, and this is what law does every day. Now this is again confusing because the legal apparatus is ever changing. It is evolving, at least in a democracy such as the one that we live in. And there are all these like imperfections, and well, there's room for improvement, definitely. So, and that's very confusing, because we think the empirical research associated to data, especially to numbers, is very precise, but indeed it's not. We think that everything associated to natural facts is more precise if we think of mathematics or physics, and we learn it's not. There's still room for improvement. Well, in between we have this blurry legal apparatus that still counts values in terms of numbers and hands out sentences to criminals in terms of years in prison. So again, this is associated with numbers, but it's very imprecise. We really don't know how to square that circle. So what we need to be aware of, where we need to be sure that we understand this, is data represents approximations, but it's not about true universal facts that are never changing. It's normative. It's always different, and it's always by our influence, whether it's about natural facts, whether it's about ethical or legal information, or whether it's about empirical research.